Random forest is an extension of decision trees, and that is one of the reasons why we see the forest label here, because a forest is just a bunch of trees. Okay, and then here we're just visualizing each of the decision trees from the random forest model. Okay, so let's run this, and here we have that. Okay, so here is the first decision tree, here we have the second decision tree, here we have the next one, decision tree number 3. This is decision tree number 4. Okay, so yeah, so that's how you can quickly visualize each of the decision trees of the random forest model. Okay, so here is the importance associated to each feature. In this case, it's recommended to sort the values from from largest to smallest, so we can do sort values by importances, ascending equals to false. Now it's sorted based on the importance. So then what this model, based on this model, right, again, the random forest with 4 trees and the depth equals to 3. So what this is telling us is that duration is the most important feature, followed by p days, and then after that is month. Okay, there is not a particular scale when it comes to the importance. Okay, so but the higher the value is, the more important that feature is. Okay, hello guys, in this tutorial we will go over the basics of random forest. Before we start, if you find value out of this video, please like and subscribe. Also, the links to the notes and to the code that you will see in this video can be found in the description box. That being said, let's get to it. Introduction to random forest. Random forest is an extension of decision trees, and that is one of the reasons why we see the forest label here, because a forest is just a bunch of trees. Okay, later on I will explain, or I will highlight the reason of the random label that we see here. Okay, so technically speaking, random forest is just a bunch of trees in parallel, and then each tree basically is going to generate a prediction, and then at the end we're going to aggregate all of those predictions to make a stronger prediction. That's basically, in plain English, what the random forest is. Okay, so let's go over the first section, introduction. So random forests are a type of ensemble learning, and ensemble learning again is just a bit a technique, or yeah, a technique that basically combines different model predictions. Okay, so it's a machine learning technique that combines model predictions. Okay, so again, random forests are a type of ensemble learning method used for classification and regression. Okay, and the reason why it can be applied in classification and regression is because random forest relies on decision trees, and we know from the previous tutorial in decision trees that decision trees can be applied for classification and regression purposes. Okay, all right, so now let's go over the basics of how random forest works. Okay, so first let's visualize what's happening here. So you're gonna start with your training data set, and the idea is to build decision trees in parallel. Okay, so the question is, how am I going to build a bunch of decision trees in parallel if I only have one data set, right? So the answer to that question is, you're going to generate copies of the training data set, but it's just not going to be just a straight copy out of the training data set. So we're going to rely on a technique called bootstrap sample. So you can generate one copy here. Let's call it bootstrap sample 1. And then here bootstrap sample 2. Let's say for illustration purposes, or in terms of math notation, bootstrap sample n. Okay. Bootstrap sample or bootstrapping in general is a statistical technique that allows you to generate data sets by taking random samples with replacement. That's basically it. Okay. So that means that there is a chance that an observation from a given data set can be selected more than once because we are taking random samples with replacement. So because of that particular feature, so not all of the bootstrap samples that you will generate for your random forest are going to be exactly the same. Okay. All right. So then that in some sense takes care of, okay, I have multiple copies of the training data set. Now the next step is just to build decision trees on each of them. Okay, so here you have one decision tree. Here you have another decision tree. Here you have another decision tree. Okay, the idea is the following, that each of these is going to generate a prediction. So here we have prediction 1. Here you have prediction 2. Here you have prediction n. And then at the end, so the random forest prediction is just the average. Okay, so it will be, oh, let me change the color. I don't like that color, so let me go back to blue. Let me go back to blue. So random forest prediction is just gonna be the average. It's gonna be prediction 1 plus prediction 2 plus plus prediction n divided by n. Okay, so that's how the random forest algorithm aggregates a bunch of predictions into one single strong prediction. Okay, so now going back to my initial comment related to random. Okay, so that's a key word when it comes to random forest. So then, and then in some sense there are two layers of randomness here. Number one is how each of these data sets are generated, right? Because it relies on this idea of taking random samples with replacement. And the second layer of randomness is how each of those decision trees are going to be built. Okay, so meaning that the number of features that is going to be, or the features that are going to be considered on each of the nodes here is going to be at random. Okay, so it's not like the same features are going to be considered to generate those splits. It's only a subset of them, and then a random selection is going to be conducted to decide which feature is the one that is going to be considered. So there are, again, just to summarize what I just said, there are two layers of randomness when it comes to random forest. Number one is how the bootstrap samples are generated, and second is what features are going to be considered to build the decision trees. Okay, because of that, we're going to add diversity to the overall ensemble, okay? Because all the predictions that you're going to generate from each of those decision trees are not going to be exactly the same. So there is going to be some diversity there. And then by taking the average of all of those predictions, so then it is very typically, you know, by taking the average, you come up with a stronger prediction, basically. Okay, and that's the idea behind random forest. Again, you start with a training data set, you generate multiple copies of the training data set by bootstrap sample or by bootstrap sampling, and then you're gonna build a decision tree on each of those bootstrap samples, and then each decision tree is gonna generate a prediction, and then you just aggregate those predictions. Okay, all right, and those are the steps that I have listed here. Okay, so when it comes to random forest, so multiple samples are drawn with replacement for the training data set. A decision tree is trained on each sample. At each node, a random subset of features is considered for splitting, and the final prediction is obtained by averaging in the case of regression or majority voting for classification. All right, let's go to the next section. Applications of random forest in data science. So random forest is being applied on many different fields. Okay, so and it's been around for a couple of decades by now. If I remember correctly, random forest, the paper um, related to random forest was published, I think, in 2001. So yeah, so it's being applied on credit scoring, medical diagnosis, customer charge, image classification, feature importance. Okay, and feature importance is a feature that in some sense allows you to identify which features are important in the random forest model. Okay, so then I will show you how to extract that later on in this video. Next section, what are the advantages associated to random forest? Number one, it handles both classification and regression, and that is due because of decision trees. Okay, so random forest uses a bunch of decision trees in parallel, and we know that decision trees can handle classification and regression. Another advantage is it reduces overfitting compared to single decision trees. But again, what I want to emphasize here is even though that by having that random selection of the features and the random generation for the bootstrap samples, that in some sense reduce some of the potential overfitting, but still you need to be careful because any machine learning model can overfit a data set. So you always need to keep an eye on overfitting. Next, it provides estimate for feature importance. Again, that's another nice feature. And it is robust to outliers and noise. Next, what are the disadvantages associated to random forest? It could be computationally expensive, especially with large data sets. Okay, so you have millions and millions of rows. You know, it may be slow to build or to train a random forest model. Okay, but again, it all depends on what computational environment you have access to. Is less interpretable than a single decision tree because now we're aggregating a bunch of decision trees, so interpretability is reduced. Okay, and next, it may not perform well with sparse data or high dimensional data. Okay, so yeah, so if you have sparse data or you have high dimensional data, meaning that you have lots of columns in your data set, random forest may not perform well in those cases. In conclusion, random forests are an essential tool for a data scientist toolkit due to their performance, flexibility, and ability to reduce overfitting, especially compared to a single decision tree. Okay, so again, if you are interested in the machine learning field or in the data science field, So random forest is just one of those algorithms that you really need to know. Okay. All right, so that's all I have in terms of the notes. Now it's time to practice some coding, and we're gonna go over some toy examples that will highlight how you can build a how you can build a random forest model, how you can extract feature importance, and then how you can train and evaluate a random forest via cross validation. Alright guys, now it's time to practice some Python coding. So this is just a toy example that will highlight how you can build a random forest model with scikit-learn, how you can extract the feature importance, how you can train and evaluate a random forest model via cross-validation. Okay, so we're gonna use the same data file that we used in the previous tutorial. So it's called the bank full data file. So then just a friendly reminder, so it has information related to bank customers, and in particular here this data was collected from a marketing campaign. Okay, the goal was to see if the bank customer will enroll to some sort of like a direct deposit. Okay, so the information that we have on the bank customers is very basic. So we have the age, the job, marital status, education, whether or not the bank customer has defaulted before, the balance, housing, and so on. And then the goal here is to use all the information that we have up to this point to predict y. So then y is the target variable in this case. No means that the customer didn't enroll to this particular term deposit. Yes, it means that the customer enroll in this term deposit. Okay, so the goal here is, I mean, from the machine learning perspective, is to use all the information up to this point to predict y. Okay, so let's run these, and then just again to have a better idea about the distribution of the target variable. So we see that this is an imbalanced data set because the proportion of zeros or the proportion of no's is much larger than the proportion of yes. Okay, and then when you are analyzing a data set with these type of characteristics, you need to be careful, especially for cross-validation purposes. So you need to make sure that all of the false, more or less, they have the same proportion of yes and no's. All right, next, basically here we start by defining the input, and the notation that we use is x. Then here we define the target variable, and the standard notation is y. And then we are mapping no to 0 and yes to 1. Then next is we're going to pre-process the input variables. Okay, so then as you can see, some of the input variables such as job, marital, education, default, and others, they have label information stored in them. So in order to be able to build the random forest model, we need to map those labels into numbers. Okay, in this case, I'm considering the ordinal encoder to do that, but again, that doesn't have to be the answer all of the time. There are other alternatives to do the encoding, but then just for illustration purposes, I'm using ordinal encoder in this video or in this tutorial. Okay, now we see that all of the, in some sense, all of the categorical variables were mapped to numbers. Now at this point, we are ready to build the model. Okay, and one thing that I want to emphasize here, especially when it comes to decision trees, random forests, and in general any model that relies on decision trees, you don't need to standardize the input data. Okay, so you can have columns that they are on different scales, and that is completely okay. The tree-based models in general will not be affected by having different scales on the input features. Okay, all right, now we're going to go ahead and build a random forest model. So we're gonna start very simple. So let's start by loading all the commands that we need from scikit-learn. So from scikit-learn.ensemble random forest classifier. Then I want to build a very simple random forest model, and then I want to visualize it so then you can see more of like what's going on. So from scalar 3, we're gonna load plot 3 and matplotlib for visualization purposes. Okay, so here we're gonna start by building the model, so or defining the model. Finding the model, so rfmd is equal to random forest. So just to keep things simple, let's consider only 4. Okay, n underscore estimators, so that's the argument that you need to keep in mind, especially with especially with random forest models. Okay, so here is where you specify how many, in some sense, decision trees you want to consider. So then here I enter 4. I want to consider only 4. And here with this argument, max depth equals to 3. So I'm emphasizing that the max depth of each of the 3 should be 3. Okay, so that's the model architecture. So 4 decision trees, each of them will have a depth equals to 3. And then here we proceed to feed the model to the data. And then next, we're going to start by visualizing. We're going to visualize the random forest model. Okay, so plt figure. Let me use big size. Let's use 10 and let's make it big. 10, 20 and 15. All right, so in this case, what we're going to do is, because there are 4 trees, right? So let's visualize all of them. So for I in range 4, and then here I'm gonna have plt subplot 2,2. Then here I proceed to build the tree. So then I'm extracting estimator I, and this is gonna be 0, then 1, then 2, and then 3. Here I'm extracting the names of the features, classes. Let's use no and yes. Fill equals to true. Rounded equals to true. Let's use font size. Font size equals to 10. Font size equals to 10. Okay, and then here let's take this decision 3 from random forest. So let's use 14. And then so here's add some comments here, visualizing the trees in the random forest. And then here I just need plt tight layout. All right, so what we're doing here is, again, here first we define what is the architecture for the random forest model that we want to build. 4 decision trees. The depth of each of the trees is going to be 3. And then here we apply that model to the data. And then here we're just visualizing each of the decision trees from the random forest model. Okay, so let's run this. And here we have that. Okay, so here is the first decision tree. Here we have the second decision tree. Here we have the next one, decision tree number 3. This is decision tree number 4. Okay, so yeah, so that's how you can quickly visualize, each of the decision trees of the random forest model. Okay, so all right, so this is a very simple decision, this is a very simple random forest model. Another of the nice features about random forest is that we can extract feature importance. Okay, so let's go ahead and do that. Let's extract the feature importance of the decision tree. So for that, basically what we need to do is the following. So then once the model is being built, so in this case it's RFMD, it's a typo here. So that is my model. So if you want to extract the feature importance, so you just do feature importances, and that'll extract the importances or the importance associated to each feature in the input data, basically. Okay, now let's just make this easier. Let's make this information easier to digest. Okay, so feature importance data frame. Let's convert this into a data frame. Okay, so feature importance equals to PD data frame. So we add the columns, we add the importances. Get rid of this, and then we can close this. Here I can feature importance. So here is the importance associated to each feature. In this case, it's recommended to sort the values from from largest to smallest. So we can do sort values by importances, ascending equals to false. Now it's sorted based on the importance. So then what this model, based on this model, right? Again, the random forest with 4 trees and the depth equals to 3. So what this is telling us is that duration is the most important feature, followed by p days, and then after that is month. Okay. There is not a particular scale when it comes to the importance. Okay. So, but the higher the value is, the more important that feature is. Okay, this is a very nice feature. Okay, that sometimes practitioners use this information as a way to identify, in some sense, important features. So then you can do some feature selection, right? So for example, in this case, we see that all of these features, they have an importance equals to 0. So then that may, that may indicate that they are not important at all. So then you could remove that from the model. Okay, but always keep in mind that, if you start going into that process of adding or removing features, always test those ideas via cross validation and see whether adding or removing the feature improves the overall performance of the model. Okay, so but yeah, so this is how you can extract the importance of each of the features in a random forest model. Next, let's go ahead and run a couple of experiments just to build and evaluate a random forest model via cross validation. Okay, so as usual, let's start by loading from scikit-learn ensemble. No, I already load random forest, so model selection. So import stratify k-fall and cross-val score. So those are the ones that I use a lot, especially when I'm just building or running experiments. So first, let's define the model. Defining the model. So once again, RFMD random forest classifier. Let's use 3 for the depth. Okay, and then defining the cross validation strategy, I use SKF as the label always, stratify. So we're using 5 false, where shuffle equals to true, random is equals to 42. Then here evaluating the model uses cross validation. So let me RFCB equals to cross val score. Let's use RCAUC and jobs equals to -1. So again, we're running a very simple cross validation experiment with cross val score. The first argument is the model, then the input data, the input, then the target, cross-validation split, how you're going to evaluate the model, and n jobs equals to -1 is just use all the available computing resources. And then here we're gonna print the mean and the standard deviation. Okay, so let's quickly run this. Shouldn't take that long. So again, when it comes to the ROC AUC score, the closer that number is to 1, the better the model is at predicting the target variable. Okay, so this is just a very common metric of performance that I always use for illustration purposes. Again, it may be applicable for your case, but then in other cases you may need to use other measures of performance. And what I always recommend is keep in mind the context of the problem, meaning that how that solution or how that model is going to be used in real life, and based on that, that's how you need to evaluate that model. Okay, so in this case, just for illustration purposes, I like to use the ROC AUC. Okay, so we see that we have an average score of 88.24. Okay, now let's see if we can improve this. So then let's just copy this, paste it here, and now let's play with the depth. So instead of 3, now let's use 5 and see if we get better results. All right, so now we have an average score of 90.13. So we went from 88.24 to 90.13. So that's an improvement. Okay, just by increasing the depth from 3 to 5, we were able to improve the overall performance of the model. So let's try one more thing. So let's now, instead of 5, let's use 7. Okay, yes, so we even have even better results. Now we have an average score of 91.26. Okay, so this right here, this very simple example highlights the importance of the depth of the tree. So initially we considered a depth equals to 3, and this was the score. Then, by increasing the depth of the tree from 3 to 7, now we have a much better score, right? An auto sample score. Okay, so the depth of the tree is very important, but again, you need to be careful, because especially when it comes to the depth of the tree, so the larger that number is, the more likely you are overfitting the data. So you always need to keep a balance when it comes to the depth of the tree. Okay, so yeah, so this very simple example highlights again how you can build a random forest model, how you can quickly visualize the decision trees in the random forest model, how you can extract the importance of each of the input features, and how you can train and evaluate a random forest model via cross-validation. Okay, so that's all I have in terms of the tutorial. Once again, if you find value out of this video, please like and subscribe, and see you on the next one.